यो चाहिँ यस्तो वाला कर्भ हुन्छ है त अनि हामीले चाहिँ के थाहा गियर शिफ्ट मेकानिजम याद गर्नु पर्यो
If you've ever tried placing thoracic pedicle screws, here you can see the back of the spine, you can see the spinous process, here's the bottom of the lamina, the joint here between T1 and T2, and there's some important landmarks. Here's the transverse process, that's kind of unique in its geometry and its shape in the setting of the thoracic spine, and the pars right here. So this is the pars of T1. I tend to use the pars as an important landmark, the joint is an important landmark, and there's a ridge that you can't see so well on this animation, but you'll be able to see better in a cadaver setting. So these landmarks are the landmarks that are important for placing the thoracic pedicle screw over here. Now if you look at this, there are a couple of landmarks that are important. One of the important landmarks is looking at the joint. So here you can see the width of the joint here. This is the superior articular process that's kind of just out of view. It's tucked in behind the inferior articular process there. But you have a sense of what the width of the joint itself looks like. Now, if you pick the midpoint of the joint, so that space right there, and divide it in half, so you're looking at the midpoint of it, it gives you this line over here. Some people use that as an indicator for where to start their pedicle screw, and I think that that is a very valid and important landmark to look at. But that's not the only position that you can place a pedicle screw. The other way of doing it is to look at this structure here. So this is the transverse process there. Here you can find the pars. You can see me just outlining the pars right there of T1. And it's important when you're trying to put a pedicle screw in here to look at the pars of the same level. So for example, if you're doing it at T2, you're not looking at this pars up here of T1, you're looking at the pars of T2 over here where it meets the TP. This is the pars of T2 over here and extrapolating it up. So the width of the pars is another important landmark. And if you look at this line and extrapolate it all the way up here, it gives you a sense of width. Now, one interesting thing about the thoracic pedicle screws is that this is the range that you have available to you when you're putting a pedicle screw in. So now if you imagine you can put a pedicle screw all the way here, kind of splitting. So again, where is that? That's at the midpoint of the joint. I always put it at the ridge, which you can't necessarily see so well on this. You can see it kind of down at T1 and here's T2. So let's look at the landmarks themselves. You can see here with pen 4, you can identify the lateral border of the pars of T1 and again T2. This is looking at the width of the joint here, so you can see the full width of the joint. Midpoint is about here, and there is the range of where you could put your screw in from a medial to lateral perspective. Similarly, here's looking at the pars, the full width of the joint, the midpoint of the joint, and again, this is the range that's available to you when you're putting your pedicle screw in terms of medial to lateral distance. Now, again, as I had mentioned before, you can't necessarily see the ridge so well in this animation, but you can see it very clearly here. Here's the ridge that I was talking about. That's kind of that ridge that meets you from the top of the transverse process down there. Here's the ridge that you see over here. From a craniocaudal perspective, I generally make my start point right on the ridge. From a medial to lateral perspective, you can get a sense of where the midpoint of the joint is, where the pars is, you extrapolate it up, and this kind of 5 to 6 millimeter range that's available to you for a thoracic pedicle screw start point. Using a gear shift when you're cannulating a thoracic pedicle. There are two general types of gear shifts that are used. There's straight gear shifts, and those are the sharper ones, which are called Lenkeys, or many people refer to them as Lenke probes. There's also some blunt ones called Steffi probes. I tend to use a Lenke probe. I like it more in terms of its geometry and its sharpness at the tip. I tend to use a straight Lenke, but not everybody does that. There's some value to using a curved Lenke as well. So let's talk a little bit about the proper use of those, or some of the principles of using a curved versus a straight gear shift. So if you imagine a thoracic pedicle, this is looking again at the pedicle, let's say an upper thoracic Lenke, it tends to have a bit of a bevel to it. So in general, like you can look at a straight Lenke will be in cross-section. I'm going to exaggerate a little bit, but it'll almost be rectangular in cross-section, and then there'll be a curved Lenke. Now, I tend to use a straight Lenke and feel my way right down the center, but some people like to use a curved Lenke. Let me talk a little bit about how that is done. When you're putting in your curved Lenke, let's assume that this full depth is about 30. Bevel, so to speak, the convex surface of it ends up being medial. So you put this in and imagine that this is the convex surface of it. That is going to be directed medially, and that's because you want this surface to brush off the cortical margin of the pedicle. So what you don't do, generally when you put this in, is you'll actually exert a bit more medialization to feel it kind of almost like come off the surface here. So you'll medialize it a bit more with the bevel medial. That's counterintuitive because in the very superficial portion of the thoracic pedicle, you generally don't over-medialize stuff. But with a curved Lenke, that's how you start it. You get to a depth of about 15 to 20. Most people say 20, and then remove it and then switch the bevel so that the bevel is directed, the convexity is directed laterally for the ventral portion of it. So here, when you put this in, you don't necessarily medialize it aggressively. There, you put it in more or less straight and hope that the bevel bounce off of the lateral edge of the vertebral body. That is the technique for putting in cannulating a pedicle using a curved Lenke. The first 20 millimeters or so, you have the bevel, which is to say the convex surface, not the point. The convex surface pointed medially, then you remove it, you turn it around, you feed it back in softly to a depth of 20 again, and then get the rest of the distance. And the rest of the distance is done without much medialization to it as a general rule. That's what I use when I'm doing it. That's how I do it when I'm doing a very small pedicle. I'll tend to do this technique because I feel like it's easier to bounce off that medial edge of the pedicle. Unlike that, when you're doing it, it is something that, if you're putting in a straight gear shift, I tend to just kind of run it down the center here. And this is something that, your straight gear shift will end up kind of redirecting you. But I tend to put it in kind of lightly using some anisotropic principles of kind of thinking the path of least resistance is usually down the center. That is something I wanted to get into right at the outset because it's kind of a valuable lesson to learn at this point, how to use a curved versus a straight Lenke when you're cannulating a thoracic pedicle. So now, after using a gear shift to cannulate the pedicle, we typically will come in with a ball tip probe, and that is really to feel the margins. I tend to feel 4 walls and a floor, so that is like a rostral, caudal, medial, lateral, and then a floor. I'll check in this case both of them to make sure that I have all 4 walls and a floor. Now, when you use a gear shift, especially in a small pedicle, you don't always have to tap, but I do tend to tap, and I will undersize tap. So if I expect to put in a 5/5 screw, for example, or in this case maybe a 5/0 screw, I will tend to tap with an undersized tap. Many people think, like, what's the point of doing that? But the reason that I tend to use a tap is to center the pilot hole, because again, I free-headed my way through the pedicle. There's a chance that I'm eccentric within the pedicle. I'm going to tap them generally just to a dip. So once I've tapped, I do check them off here, just demonstrating that, it's again collinear. These start with 1 screw and do the same thing, and have it on the screwdriver and putting it in. Once the screws are in, you can really see here how here you can see that the alignment. And so that's kind of a higher order, kind of interesting thought to put into it, because again, you have some range of medial to lateral